Now let's start the last section of today's lecture. I mentioned this term scope multiple times by now, and you may be wondering about what that is, right? So scope is the range something has power on. So let's see. There is a static scope and dynamic scope. Static and dynamic. Static meaning before running. Dynamic meaning during running. So when we talk about analysis or checking or things like that, there are two things: static checking and dynamic checking. Static something and dynamic something. Static analysis, dynamic analysis. When we say that, static meaning it's like compile time. And when we talk about dynamic, it's runtime, which implies that runtime during execution, at runtime. Compile time meaning before execution, before running code. Okay? Then static scope meaning that the scope is determined before running the code, before running programs. Dynamic scope meaning that the scope is determined at runtime. That's the biggest difference. In a language with static scope, the scope of an identifier's binding is a syntactically delimited region, meaning that when we have an identifier, and whether the identifier is available here or there, that's the scope. Okay, the scope of an identifier's binding, meaning that an identifier is introduced here. An identifier is introduced here, then where it is available, where is it available? It's going to be available only here, E1, E2, only in E2. That's what we have been talking about. That was the semantics of this expression. One more time. When we have this syntactically delimited region, syntactically delimited region, 문법적으로 여기부터 여기까지라고 그냥 분명하죠? This is the scope, syntactically delimited region. The name introduced here, the identifier's binding, it has the scope, which is this, E2. That's static scoping, meaning that X is not available in E1. Dynamic scope. In a language with dynamic scope, the scope of an identifier's binding is the entire remainder of the execution during which that binding is in effect. Meaning that at compile time, before running the code, we don't know how far and where this name X is available. Let's look at this example. Here we have a function def for function, right? Function named f, whose parameter name is p, whose body expression is n. Oh, okay. This is the function definition. And now we have this one expression. We are introducing a name n here. N's value is 5. And we'd like to evaluate this function call. In static scope, n is available. The scope of an identifier's binding. The scope of n's binding is a syntactically delimited region, meaning that n is only available from here to there. So the semantics, according to the semantics of this expression, n is available only here, not here. No. Okay? So, meaning that n's scope is that, but we do not use n there, so we do not use n's value. In static scope, we evaluate a function called f10. Oh, what is f? Look up the function definition. It's that. We are going to evaluate this argument expression 10, and the value is going to be what? The value of the parameter p. So n is 5 here, p is 10 here, and in this scope, n is free. Free identifier error. Free is not really good. 자유롭다고 좋은 게 아니죠. It's an error. How about dynamic scoping? If we are talking about dynamic scoping, oh, that's a bit different. In a language with dynamic scope, the scope of an identifier's binding, the scope of n is the entire remainder of the execution during which the binding is in effect, meaning that n is available in the entire remainder of the execution. So when we are evaluating this one, F10, n is still available, and F's definition is that 10 is going to be bound to P, and when we interpret this function body, n is still available, so n's value is 5. That's dynamic scoping. So with static scope, this code signals an error. Which error was that? Free identifier error. With dynamic scope, the code evaluates to 5. Why? Because n is 5, evaluate F10, go there, P's value is 10, n's value is 5. So, dynamic scope may make sense to some of you, and static scope may make sense to some of you. And actually, depending on how you feel and how you implement your code, dynamic scoping could be more tempting, could be more attractive. 다이내믹 스코프를 하고 싶을 수 있어요. Because we have more information. Why do we waste this information? Because it's really, really error prone. One more time. Error prone. And it's difficult to reason about. Why? Because with static scope, it's simple. Just from here to there, and n should be available only here. That's it. We do not need to go beyond this syntactically delimited region. We only need to look at this. That's it. Very simple. But dynamic scope, we need to remember when the value was introduced and whether it was hidden by the other value or not. It's really difficult. That's why it's error prone, because we are not people, or we are not computers that can remember everything, right? And it's because of that, because it's difficult to remember, difficult to reason about. Because it's difficult to reason about, it's easy to make errors. So dynamic scoping, long time ago, the language called Lisp once had this dynamic scoping, and people, the very smart people who developed this language called Lisp, they agree that there was a historical mistake that they allowed to have dynamic scoping. In these modern timing, these days, no real reasonable language has dynamic scoping. Almost every practical programming language uses static scope. So then what does that mean in this context with F1VAE? Right? That's our main interest. Why are we talking about this scope and dynamic scope? And how do we represent that in this interpreter implementation? In this interpreter implementation, let's review one more time. We'd like to interpret an expression which is happen to be function call. F for function name string, A for the argument expression, expr. Then, using this function name, F, we investigate the list of function definitions, look up the fundef of this name. If there is nothing like that, it's an error right here. If there is one fundef, then we get it. And the name, F name, should be the same. It should have some parameter name and body expression. Just like twice, that's F name and F. Open parameter X, that's P name, X, equals open X plus X. This is body. Then, when we call this function twice with 42, then this A is 42. So we interpret 42, interpret the argument expression under the given environment, and using the given list of function definitions, evaluate it. We get the value 42. And then interpret body x plus x. Interpret body using the list of function definitions under which environment? That's the question. What do you know? I know there could be one empty environment. And I know here's EMV. And what else? If we use empty environment here, when we evaluate the body expression, whenever we have a name, we don't know its value. Because when we evaluate the body expression, whenever we have a name, we need to look up the environment. There's nothing. It's a free identifier error. That's not what we want. Then, when we evaluate the body expression, what do we want? At least we want to know the value of the parameter. So here we need to put this information saying the parameter name, what? P name, right? The parameter name that has which value? Argument value. Meaning that this x has value 42. So when we interpret the body expression using this list of function definitions, at least we need this piece of information saying the parameter name x has argument value. Where did you get this argument value? By interpreting the argument expression. Are you with me? Okay, then. We need this information, the value of the parameter, when we evaluate the body. What else? What else? There could be at least two options. One, empty. Two, EMV. Right? Do you see it? What do you want? What do you want? If it's empty, yeah? If it's empty, which meaning map, open, close, meaning that when we interpret this body expression, there's only one identifier parameter whose value is passed from the function call side. Okay? If we use EMV, what is it? It's gonna have the name value information from the call side, which is what? Dynamic scope that we do not want to have. So, because this language, F1VAE, it has static scope, we want to have the empty environment and one piece of information saying the parameter name has this argument value. If it was dynamic scope, which is weird, but you know, some people are weird, then what are we going to have? That should be ENV plus P name A val. If I'm crazy, I may have crazy symmetrics. I mean, crazy scope. Yeah, you know, some people I could be crazy. Then what can I have? I can have EMV. Ooh, because type-wise, everything is EMV, so I'm good. But what? When I evaluate the body expression, when I encounter the parameter name P here, then because the environment doesn't have this value, I'm gonna throw an error. Very weird semantics, right? So, which implies that all this implementation, it's just different semantics. Even though we have the same syntax, we can have two different semantics. Meaning that in your midterm exam, you may have some language and we may give you two different implementation and ask you to compare their semantics. Oh, isn't it cool? So, exercise number 4 already is available from Piazza. And first of the functions, there are 2, again, in Korean and English documents. If you are not sure whether you got the material today, I strongly recommend you to read this document and do the exercise number 4. Thank you.